medicine capsule is in the shape of a cylinder with two hemispheres stuck to each other. So we have here a cylinder, this is the capsule, this is a cylinder, so we just make it's a cylinder with these two hemispheres stuck to each other. The length of the entire capsule is 14 mm. So this entire capsule from here to here is 14 mm. While the diameter is 5 mm. So that is 5 mm. Fine, we need to find its surface. So if you look at this capsule now, there is a cylinder here. Here you have, this is a cylinder. Okay, this. Now this cylinder, the height is not given, we need to find. However, the radius of the cylinder is 2.5 mm. How did we get 2.5 mm? Because this entire radius, have you seen, this entire diameter, have you seen, was 5 mm. It was given to us that the diameter is 5 mm, so the radius will be 2.5 mm. And then we have the cone, we have not the cone, the hemisphere, and for the hemisphere we need to find only one dimension, and that is the radius. Again here we see that the diameter is given as 5 mm. They both share the same diameter, the cylinder and the hemisphere, and the radius so will be 2.5 mm. Now what is important is to find out the height of the cylinder. To find out the height of the cylinder, we do it like the earlier sum. This total length is given as 14 mm. Now this 14 mm right from this end to this end is 14 mm. It is divided into three parts. One is this radius plus this central height. So the total height, which is 14 mm, is divided into three parts. We have the radius plus the height plus the radius. Now out of this we already know the radius. The radius is 2.5. We do not know the height. Here the radius is 2.5. So 14 equal to 2.5. 2.5 is 5 plus height. So the height is 14 minus 5, and 9 is the height. So the height of this is the height of the cylinder. So let's go back to what we didn't know. We didn't know this height. Now this height is 9 centimeters. We got it from here, 9 centimeters. Continue with the sum. Remember we have to find the total surface area of this capsule. So the total surface area of this capsule now will be this surface, which is the CSA of the cylinder. Why not the TSA? Because the TSA is covered up here. Okay, have you seen, this is the cylinder, right? This part, they take only this part, this and this part. This part is not taken because here it is attached to the hemisphere. Even for the hemisphere, this part of the hemisphere is not taken. Only the outer surface is to be taken. So here we have, this is the CSA of the cylinder. Then we need to take this surface, and this surface. Now both these surfaces are the CSA of hemisphere, which is 2 pi r square, and this also is 2 pi r square. So the TSA of this figure has got 3. This is 1, which is 2 pi RH. Then it has got this 2, which is 2 pi r square, and it has got this third one, which is another 2 pi r square. We now substitute the values. So we start here with 2 pi. We know the r is 2.5 and the h is 9, plus here this 2 pi r square, we're going to add up and do 4 pi r square. So 2 pi, and this will be 2, when you multiply this you will get 45 pi plus 4 pi, and your r here is 2.5 square. So here you will get 45 pi plus 25 pi, and that will work as 70 pi. And now we will substitute the value of pi as 22 by 7, and the answer is 220 meter square.